All right, today is another sample problem. Probably take us the whole 30-ish minute period to get through it. If you have questions, please ask. Make sure you learn where the hand raise button is on whatever device you're using. I think you swipe up from the bottom on smartphones, and I think it's under the participants tab on computers. We will be doing some more practice after spring break. And again, I hope I don't get, don't know if I can say this too much or not. Just relax. Don't get panicked if you're not knowing it yet. There are a lot of people who take several times through before they start to get all of it. And it turns out that just like memorizing a Bible passage, the first verses are easier to memorize than the last verses, because if you say it to yourself, you start at the beginning and you start with the first verses and then memorize the next one and the next one. So some of the later steps people have a harder time remembering because they just are starting to forget things by the time they get there. All right, so here are a list of steps. This time I have all of the steps there, and we'll go through them and I'll do it. If you, I kind of suggest at this point that you take a piece of paper and write down, copy down what we're doing. And I actually suggest that if possible, you try and stay one step ahead of me so that you can kind of see if you can do it. And if you can't, you can follow the explanation. And if you do get the next step done, then you can check to see if you did it right. Obviously, there's no way I can enforce that. So, but that's what I suggest. So, first step, A, determine what is oxidized and reduced using oxidation numbers. Now you see all of these are ions. Now remember, before we go any farther, what you see there is the original equation. I'm going to get rid of the 2, maybe, so that you're not confused by it. That is the original equation. When we get down to step G, where it said, and we're not there yet, but when we get down to step G, where it says rewrite the original equation, this is what we write. Anything we are about to write up top does not become part of the original equation. And we'll point that out again when we get down to step G. So we're on step A, determine what's oxidized and what's reduced. And I'm going to zip through this because you're supposed to know what's going on by now. So oxygen is -2, and there are 3 of them, and it has to add up to -2 because of this charge right here. So let's see, that's -6. This must be +2 times 2. That would be +4 minus 6 is -2. Oxygen is almost always -2. Now, chlorine is in group 7A, so we would normally say it's -1, but -1 would not add up to this charge of this ion. So in this case, that's why it's almost always, but not always. In this case, the oxygen rule is stronger, so the chlorine is +1. This is the simple one. Ions are the same as their charge, so chlorine is -1. And here we have sulfate. Oxygen is -2, and there is 4 of them, and it has to equal -2. So sulfur must be +6, because 6 minus 8 is minus 2. It's supposed to be a 4. Looks like I might have dragged the point a little bit. All right, so now we have to see what goes up. Up is oxidized. So sulfur goes from +2 to +6. Well, that's the up. So oxidized is sulfur. And then reduced is what goes down. Oxygen goes from -2 to -2 to -2, so that's not it. Chlorine goes from +1 to -1, so that's a decrease, so reduced is chlorine. Now, hang on for a minute. I'm about to sneeze. Starting to get a little bit of hay fever on top of everything else. Sorry about that. All right, so now we're at step B, which is write the half reactions. 1 and 1, so 2 half reactions. And right now, you should read out loud to yourself. You don't need to turn your mic on. You should read out loud to yourself what we need for this. There are 3 things we need. We need symbol, subscript, and oxidation number in the half reactions. So, symbol, S, subscript is right there, 2. Oxidation number is right there, +2. All right, now the right side arrow, symbol is S still. Subscript is an understood 1, and the oxidation number is +6. If you have questions, click the raise your hand button. Okay, now for reduced, symbol Cl, subscript understood 1, oxidation number right there, +1. Now the right side, symbol Cl still, subscript understood 1, and the oxidation number is -1. Good? Questions? Now we have balance, balance, balance. So balance the elements with coefficients for step C. Here we have 2 S's on the left, subscript 2, subscript 1. So we'll need to add a coefficient of 2 so that we've got 2 S's on both sides. Now the other half reaction, 1 Cl and 1 Cl, that one's already good. Now, step D, balance the charges by adding electrons. Now, I had you write something down there. You should say it out loud to yourself again. You will multiply what? You will multiply coefficient times subscript times oxidation number. So it is 1 times 2 times +2 is +4. And then 2 times 1 times 6 is +12. Remember, we're adding electrons, which is subtracting. So 4 is 12 minus 8. And this -8 becomes +8 electrons. Whoops, 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 whoops. Where's the 8? What am I doing? +8 electrons. And remember, this says plus, And this says negative because minus is the same. That looks like equals, sorry. Minus is the same as plus a negative. All right, so we're done with this. That was just a tool. Now we do the other half reaction. This one's too easy. 1 times 1 times 1, ooh, plus 1. And on the right, 1 times 1, whoops, didn't mean to put that little line there, times minus 1 is, this is rough, minus 1. Now, if you're awkward with your negative numbers, you might not notice that this should be minus 2. So minus 2 plus 1 is minus 1. And that means that this becomes plus 2 electrons. And we're done with this. Any questions? All right. Step E, balance the electrons between the two half reactions using least common multiples. So the least common multiple of 2 and 8 is 8. So we have to multiply 2 times 4 to get 8. So we'll have to multiply each equation, each coefficient by 4 in this half reaction, making myself some room here. No, come on. So 2 times 4 is 8. And 1 times 4 is 4. And 1 times 4 is 4. Now, questions? You good with that? Technically, we have to multiply this by 1. So 1 times 8 is 8, 1 times 2 is 2, and 1 times 1 is 1. Only the coefficients get multiplied through, not the subscripts. Cancel the electrons and add the two half reactions. So we're done with these. We have 8 given, 8 taken. That's good news. So add the two half reactions. On the left, we've got S2 plus 2 and 4Cl plus 1. And then on the right, we've got 2S plus 6 and 4Cl minus 1. So now we're at the if-then, and we have to look back at our original equation. Now we're done with everything I wrote up here, and to avoid confusion, I hope this avoids confusion, or shall we say to not be distracted by our previous work, I'm getting rid of the previous work and just going back to the original equation. So it says, if there are elements in the original equation that were not in F, this is F right here. So is there anything in this equation that is not in this equation? The answer is yes, all those oxygens. So takes us to step G. Rewrite the original equation and insert the coefficients from F. So I rewrite the original equation. Excuse me. S2O3 2 negative plus OCl 1 negative arrow CL1 negative plus SO4 2 negative. Now we'll drop in coefficients from step F, which is right here. Sorry. So the S2 has nothing in front of it. The S2 came from right here. So this understood 1 goes right there. Stays just like it is, an understood 1. The CL came from this compound. So the coefficient of 4, can't put coefficients in the middle, have to put it at the beginning. On the right, now notice this, I did not write them in the same order. The first coefficient here is 2 in front of the S. The S is not the first thing in the original equation. Well, this 2 goes with the S, so in the equation I have to write it with wherever the S came from, which is right there. And the 4 goes with the CL, so I have to keep it with the CL. Now, you good with that? Any questions? Now, I don't know that I recommend that you do this, but we are done with everything from here up. We're not looking at that anymore. Do not cross it all off on a test or PFG before you hand it in. But so that you're not distracted. Step H. Warning. Step H frequently doesn't get done. It's almost always not needed, but that doesn't mean you can just skip it, because if it is needed, it's needed. If it is needed and you don't do it, you'll never get the right answer. So step H, balance any non-redox elements. Well, the redox elements were S and Cl. So what else is there? O. O, O, O. O'Reilly's Auto Parts. Woo! There, I said it for you. So balance any non-redox except hydrogen and oxygen. Well, that's all we got is oxygen, so we don't need this step, like usual. Balance any other charges, except now we're not adding electrons, we're adding hydrogen ions, H+. Now, folks, careful, careful, careful. This works kind of like the previous step, D, except it doesn't work exactly like D. So you're going to want to write this down in your notes by step I. By step I, write coefficient. I don't have a lot of room in this because I shrunk it. Times oxidation number. So in this step, we're doing coefficient times oxidation number. So coefficient of 1 times oxidation number of -2 makes this -2. If you have questions, click on that, raise your hand button. Coefficient of 4 times oxidation number -1 makes -4. So the left side adds up to -6. On the right, 4 times -4, I don't know what I'm thinking. 4 times -1 is -4. 2 times -2 is -4. So the right side adds up to -8. Now, in the other step where we balance charges, we had to subtract from the high side because we're adding electrons. Here we have to add to the low side because we're adding hydrogens. So -6 does not equal minus 8. Minus 6 equals minus 8 plus 2. And this plus 2 has to become plus 2H plus. The plus 2 becomes that, plus 2H plus. Questions with that? Yes, Sid?
How do we know which compound on the right side to add the hydrogens to? Like, couldn't we just add it to Cl, or is there a reason why?
We're not really adding it to the SO4.
Oh, right. Sorry. Yep.
We're just
got it.
adding it to the right side of the equation. One more thing on the right. Sometimes it will be on the left. And frankly, I could have squeezed it in right here if I hadn't wanted to. I don't know. Can you see my little dot going around circles? Or doesn't that come through to you all? So I could have squeezed it in right here if I had wanted to. All right, the last step. So the last step says balance hydrogen and oxygen by adding water. Now, you don't do them both at the same time. You either do the hydrogens and check the oxygen, or you do the oxygen and check the hydrogen. So I think it's usually easier to do hydrogens, maybe not, but it feels to me like it is. So how many hydrogens do I have on this side? How many hydrogens here? I don't see any hydrogens, Mr. Carpenter. Me either. How many hydrogens here? Still none. So 0 hydrogens on the left. None here, 2 on the right. So how many H, okay, this is a trick question. How many H2Os does it take to get 2 H's? Well, I'm thinking 1. So we won't write a coefficient here. We'll leave that an understood 1. Now, if we did this right, we should have the same number of oxygens on both sides. So let's add them up. Here we've got 1 times 1 is 1 oxygen. 1 times 3 is 3 oxygens. And 4 times 1 is 4 oxygens, for a total of 8 oxygens on the left side. Now we'll add up the right side. Here we have none. Here we have 2 times 4 is 8 and none. So let's see, 8 oxygens on the right, 8 oxygens on the left. They match. We did it right. That's your easy check on these, is if you do the hydrogens and the oxygens line up, or do the hydrogens and the oxygens line up, you do one, the other one lines up, then you did it right. So there is our complete process all the way through, final answer. It took us almost half an hour to do it, but I was going through slowly, explaining everything. Once you get the hang of it, it's a few minutes. Any questions? All right, again, we will be doing more of these after spring break. Enjoy your spring break. I mean, you know, you can what? Take a trip from your bedroom to the basement or something. But at least you don't have to listen to class and figure out how to do problems. You do have a quiz. Please get it taken by 3 o'clock. Guess I'll mark that we did letter step J. And we'll see you in, I guess it must be 10 days. So you all enjoy your spring break.